In 1968, if you boarded a commercial flight, your odds of dying on that flight were roughly 1 in 350,000. By 2022, that number was 1 in 13.7 million. Commercial aviation roughly doubled in safety every decade for 50 years, while carrying exponentially more passengers across more routes, in more countries, with more aircraft types, more pilots, more complexity in every direction. The likelihood of being killed in a commercial air crash today is approximately 1/17th what it was 30 years ago. This didn't happen because planes became miraculous. It happened because aviation built something that no other industry has replicated at scale. A system specifically designed to treat every failure as information, to make it structurally impossible for a crash to be documented and then forgotten, and to strip the authority figures inside the system of their ability to decide which failures were worth learning from. The industry got there by crashing, and deciding finally that the crashes were not bad luck. They were a problem born of consensus. This is the 10th Man Podcast. Welcome back to the 10th Man. I'm Chris Porden. We've spent 3 episodes watching institutions fail in ways that should have been preventable. Israeli intelligence in 1973, NASA and Morton Thiokol in 1986, medicine for 2,000 years. Different domains, same structure. The people with the authority to act also controlled which information reached them and which conclusions were permitted. This episode is different. This episode is about an industry that looked at its catastrophic failure rate, identified the structural cause, and actually fixed it. Not perfectly, and not permanently. The residue of this episode is Boeing's 737 MAX, which killed 346 people in 2018 and 19 because a specific piece of the safety architecture was selectively dismantled under commercial pressure. But the arc of this story is, for the first time in this series, one of genuine institutional learning and understanding how aviation did it. Exactly what it changed and exactly what it cost is the most useful thing this episode can offer. To understand what the aviation industry built, you have to understand what it was replacing. The culture of commercial aviation in the 1970s had an important governing principle, inherited from the earliest days of flight. The captain's authority was absolute. In the cockpit, what the captain says goes. This was not a written rule, but it was a professional norm so deeply embedded that subordinates were socialized into it before they ever sat in a cockpit professionally. You did not challenge captains. You deferred to them. You found indirect ways to communicate concern and hoped they would notice. This had a name. Investigators would later call it hinting and hoping. There were reasons the norm existed. In the early years of aviation, the captain's superior skill and experience were genuinely the primary safety margin. A co-pilot challenging a captain's decision could create confusion in a high workload environment with catastrophic results. The hierarchy was functional when the captain's judgment was reliable and the failure modes were mechanical. What investigators began to notice in the 1970s was that this condition had changed. Aircraft systems had become complex enough that no single human, regardless of experience, could reliably process all available information alone in a crisis. The failure modes had shifted, and yet the hierarchy had not. The result? 70 to 80% of aviation accidents in this era involved human error rather than equipment failure or weather. NASA's studies of cockpit dynamics found that most of those errors consisted of failures in leadership, team coordination, and decision-making, not failures of individual competence. Failures of the system that organized individual competence into a collective outcome. The norm was the problem, and it was about to demonstrate exactly what it cost. March 27, 1977. Tenerife, Canary Islands. Two Boeing 747s had been diverted from Gran Canaria after a terrorist bomb forced an airport closure. The airport was overwhelmed, aircraft parked on taxiways, limited ground radar, a fog rolling in across the single runway. Two of the world's largest passenger jets were using that runway as a taxiway. The KLM 747 was piloted by Captain Jacob Veldhuisen van Zanten. He was not a reckless man. He was KLM's chief flight instructor, the most senior active pilot at the airline. He appeared in KLM's promotional materials. He was the face of the carrier's safety program. When the crash was reported and KLM management scrambled to find their top 747 jet captain to help with the investigation, it took hours for them to realize he was the one who had just died in the crash. Van Zanten was facing time pressure. His crew was approaching their duty time limit, the maximum hours permitted before regulations required rest. He had made the decision to fully refuel at Tenerife, which added time on the ground. He needed to depart. The fog was thick. The Pan Am 747 was still on the runway, taxiing toward its designated exit. The controller could not see either aircraft. Van Zanten received a departure routing clearance, instructions for which headings and altitudes to fly after takeoff. This is not the same as clearance to take off. The distinction matters in every pilot's training. Van Zanten began his takeoff roll. His flight engineer heard something on the radio that gave him pause. The Pan Am crew had transmitted that they were still on the runway. In the cockpit of the KLM jet, accelerating down the same runway, the flight engineer asked the pilots, "Is he not clear, that Pan American?" Van Zanten replied, "Oh, yes." The KLM 747 hit the Pan Am 747 at takeoff speed. 583 people died. It remains the deadliest aviation accident in history. The flight engineer was right. He said something. The hierarchy overrode him in 2 words, from the most authoritative voice in the room, without deliberation. The correct information existed in the cockpit. There was no structural mechanism to give it weight against the captain's certainty. This is Yom Kippur with different hardware. The warning was present. The framework consumed it. The following year, December 28, 1978, Portland, Oregon. United Airlines Flight 173 was a DC-8 making its approach to Portland International Airport. As the landing gear extended, the crew felt an abnormal vibration and yaw and received no confirmation light that the gear had locked down properly. Captain Malbern McBroom, an experienced and respected pilot, made the prudent decision to enter a holding pattern. They would troubleshoot the landing gear, determine its status, prepare the passengers for a possible emergency landing. They circled for an hour. During that hour, the first officer and the flight engineer both noticed that the fuel was running out. The DC-8's gear was extended, its flaps partially deployed. The configuration generated far higher fuel burn than normal cruise. They watched the gauges. They raised the fuel situation repeatedly in the way that subordinates in that culture raised concerns with captains. Indirectly, softly, deferentially, hinting, hoping the captain would hear it. At one point, the first officer told the captain, "We're going to lose an engine." The captain said, "Why?" The first officer said again, "We're losing an engine." The captain asked, "Why?" The first officer said, "Fuel." It was too late. All 4 engines flamed out. The DC-8 crashed into a wooded neighborhood 6 miles short of the runway. 10 people died. An NTSB investigation followed, led by aviation psychologist Alan Deal. The probable cause finding was direct. The flight crew failed to monitor fuel state. But Deal's analysis went further. The crew had not failed to monitor fuel state out of negligence. They had communicated their concerns and been unable to make those concerns register with the captain. The structural organization of the cockpit, the authority gradient, the norm of deference, the lack of any protocol requiring a subordinate to assert rather than hint, had made it functionally impossible for the correct information to change the outcome. Deal wrote what became NTSB Safety Recommendation A7947, calling on the FAA to direct airlines to train crews in principles of flight deck resource management, with particular emphasis on the merits of participative management for captains. In 1981, United Airlines implemented the first cockpit resource management program in history. The concept had a name, coined by NASA psychologist John Lauber: crew resource management. Its premise was simple, and for its moment, radical. The hierarchy in the cockpit would not be eliminated. Captains would remain captains. But the culture surrounding that hierarchy would change. Co-pilots would be trained to question. Captains would be trained to expect questioning. The crew would be an active resource, not a deferential audience. The captain was no longer permitted to be God. The captain was required to be a team leader. The distinction, in practice, is the difference between Portland 1978 and what came next. July 19th, 1989. United Airlines Flight 232, a DC-10 departing Denver for Chicago. At 37,000 feet, the tail-mounted engine suffered a catastrophic failure. A fan disc fractured at a manufacturing flaw. The disc exploded through the engine housing and severed all three of the aircraft's hydraulic lines, the systems that controlled the flight surfaces. The DC-10 had no rudder, no ailerons, no elevator, no nose-wheel steering, nothing. The aircraft was, by any engineering analysis, unflyable. When investigators later put the same failure conditions into flight simulators and tested experienced crews under them, most crashed before reaching the airport. Captain Al Haynes did something that would not have happened in 1978. He opened the cockpit. A DC-10 instructor pilot named Denny Fitch was riding as a passenger that day. Haynes invited him into the cockpit, gave him manual control of the thrust levers on the two remaining engines, the only control surface the crew still had, and built a four-person team to fly an unflyable airplane. Haynes was on the yoke, First Officer Bill Records was on the yoke, Flight Engineer Dudley Dvorak managing systems, Fitch on the throttles. They talked through every decision. They cross-checked. They argued options. They landed the aircraft. Not cleanly. The right wing dipped and the plane cartwheeled on the runway. But they landed it. 185 of the 296 people on board survived. Haynes later described what CRM made possible in language that belongs in this series. He said, "Up until 1980, we kind of worked on the concept that the captain was the authority on the aircraft. What he said goes. And we lost a few airplanes because of that. Sometimes the captain isn't as smart as we thought he was. We had 103 years of flying experience there in the cockpit trying to get that airplane on the ground, not 1 minute of which we had actually practiced under those failure conditions. So why would I know more about getting that airplane on the ground under those conditions than the other three? Why would I know more than the other three?" That sentence is what institutionalized humility sounds like. Not the performance of humility, the structural embedding of it, trained into every crew member, practiced in simulators, evaluated in check rides, built into the culture until it was no longer a personal virtue, but a professional expectation. Tenerife to Sioux City is 11 years. In 11 years, aviation had changed what a captain was permitted to be. CRM addresses what happens inside the cockpit. The NTSB addresses what happens after the cockpit hits the ground. These are related innovations, but distinct ones, and understanding both is necessary to understand what aviation actually built. The NTSB was established in 1967. Its original design had a structural flaw. It reported to the Department of Transportation, which also housed the FAA, the agency responsible for regulating aviation. The NTSB was investigating the same regulatory apparatus it answered to. The 1974 Independent Safety Board Act corrected this. The NTSB became completely independent. No agency of the executive branch could direct its investigations, and its members served fixed terms and could not be removed for political reasons. The independence matters because of what the NTSB is designed to produce. Not accountability, not punishment, information. The NTSB's findings cannot be used in civil litigation. This single design feature changes the entire incentive structure of the investigation. In every other context where something goes wrong and people die, the parties with information have powerful reasons to protect it. The airline doesn't want to admit the procedure was deficient. The manufacturer doesn't want to admit the design was flawed. The pilot's survivors don't want to admit crew error contributed. Everyone's lawyers tell everyone to say as little as possible. The NTSB severs that incentive. You can tell the investigation anything, exactly what you knew, when you knew it, what you chose not to do, what the internal pressure was, and none of it can be used against you in the lawsuit that follows. The truth becomes the safe option. The investigation becomes structurally a no-blame process in an environment where blame would otherwise dominate everything. Every finding goes into a public record. Every recommendation is formally tracked. Every agency that receives a recommendation must respond in writing within 90 days, either committing to implementation or explaining the refusal. Since 1967, the NTSB has issued more than 15,500 safety recommendations. 82% of those that have been closed were implemented. The cumulative effect is that every crash in aviation becomes a permanent public lesson. The same failure cannot be repeated without the industry having consciously chosen to ignore what it already knew. The information propagates. The system learns. This is the feedback architecture the episode opened with. Not better pilots, not better planes. A system that treats failure as data, strips the defensive incentives from the reporting process, and makes the lessons mandatory. Everything described in this episode was real. The safety record it produced was real. And then Boeing built the 737 MAX, and 346 people died. And the investigation revealed that the specific failure mode was the one this whole architecture was designed to prevent. Here is the sequence. Airbus developed an updated version of its A320, the A320neo, with more fuel-efficient engines. The engines were larger. Boeing needed to compete with an equivalent product and needed to do it fast. The solution was to upgrade the existing 737 with larger engines. The engines were repositioned, mounted further forward and higher on the wing to accommodate their size. This changed the aircraft's flight characteristics tremendously. In certain conditions, the nose had a tendency to pitch up. Boeing needed a software fix. They developed the Maneuvering Characteristics Augmentation System, MCAS. MCAS would detect the nose pitching up and automatically push it back down. The system was designed, in Boeing's initial documentation to the FAA, to operate in a narrow range of circumstances and with limited authority over the aircraft's movement. The system was then quietly expanded. More authority, broader activation conditions, without an equivalent safety review. And then it was hidden. Boeing's chief technical pilot on the MAX program arranged to have all mention of MCAS removed from the pilot manual. The rationale was commercial. If MCAS appeared in the manual as a significant new system, regulators might require simulator training for pilots transitioning from the 737 to the MAX. That training requirement would cost Boeing's customers money. Boeing had offered Southwest Airlines a rebate of $1 million per plane if no simulator training was ultimately required. The pressure to suppress the system's existence was financial and explicit. The FAA, which by 2018 was certifying only 4% of Boeing's work directly, having delegated the other 96% back to Boeing, did not have a complete understanding of MCAS at the time of certification. On October 29, 2018, Lion Air Flight 610 departed Jakarta. 13 minutes after takeoff, MCAS activated based on a faulty angle of attack sensor reading. It pushed the nose down. The pilots countered. MCAS activated again and again. It activated more than 20 times in 10 minutes. The crew had not been told the system existed. They had no procedure for it. They could not overpower it. The aircraft crashed into the Java Sea. All 189 people on board died. Boeing issued a bulletin. The FAA issued an airworthiness directive. Neither grounded the aircraft. On March 10, 2019, Ethiopian Airlines Flight 302 departed Addis Ababa. 6 minutes after takeoff, the same failure sequence. The pilots followed procedure Boeing had issued after the first crash. The procedure did not work. All 157 people aboard died. The aircraft was grounded 20 months after the first crash. The investigation produced a specific diagnosis. A Department of Transportation Inspector General review found that Boeing had considered certain MCAS failure scenarios catastrophic in its own internal analysis, but had classified that document as internal only, not a certification deliverable, and therefore had not submitted it to the FAA for review. The FAA's certification was conducted in partial ignorance of Boeing's own safety conclusions. The structural failure here is different from everything else in this series. At Tenerife, the flight engineer raised the warning and was overruled. At Portland, the first officer hinted at the problem and was not heard. At Challenger, the engineers presented data and were removed from the room. In each case, the dissent existed. The mechanism to give it weight was absent or insufficient. The 737 MAX is different. The dissent mechanism was not weak. It was prevented from forming. MCAS was erased from the documentation before any pilot could object to it. The warning that should have propagated through the safety system, a new, powerful single point of failure flight control system that pilots had no knowledge of, was never filed. It was an internal document only. The NTSB's architecture assumes that failures will be reported. The FAA's certification process assumes that safety-critical information will be submitted. Boeing made the decision that neither assumption would apply to this information. 346 people died because a commercial incentive, avoiding simulator training costs, was permitted to override the entire information architecture that aviation had built over 50 years of learning from crashes. 4 episodes in, the pattern is consistent enough that it has a real shape. In the Yom Kippur story, the framework ate the evidence. The conclusion was protected from the information that should have changed it. No structural mechanism existed to force a challenge. In the Challenger story, the dissent existed but was weightless. Engineers were right, documented it, and were removed from the room where the decision was made. In medicine, 2,000 years of confident consensus generating lethal recommendations until a sealed envelope was invented to remove the confident physician from the answer. In aviation, a culture that organized cockpit authority into a death trap, then built CRM and the NTSB to systematically dismantle it, doubling safety every decade for 50 years. And then Boeing, under commercial pressure, erased a safety-critical system from its own documentation, hid it from the regulator, and killed 346 people. The Tenerife flight engineer asked, "Is he not clear that Pan American?" 2 words from the captain ended the conversation. The dissent was present. The mechanism to give it weight was absent. 11 years later, Al Haynes invited a passenger into the cockpit and said, "Why would I know more than the other 3? And 185 people survived an unsurvivable situation. The distance between those 2 moments is what institutional design can accomplish. The distance between the NTSB's 50-year safety architecture and the 737 MAX is what happens when that design is selectively abandoned for a commercial incentive. The failure is not moral. It is structural, which is exactly why it keeps happening. In our next episode, finance. How the most systematically irrational market in the world periodically produces people whose explicit job is to assume the consensus is wrong, and what it costs them to hold that position when everyone else is getting rich going in the other direction. Thanks for listening to The 10th Man.